Mathematics and Physics 11th part. Today, numerical problems on differentiation. So, the previous class we studied 12 different rules of differentiation, and we will apply those rules to solve different problems on differentiation. The first one, d by dx of 1 by x. This can be written as d by dx of 1 by x power 1, because to apply the power rule, we need a power for the variable. Here power is 1, which can also be written as d by dx of x power 1 when it goes up. This will become x power minus 1. Now, we know the change this power rule. D by dx of x power n is equal n into x power n minus 1. Here if you compare this one, here we have x here, we have power 1. So here power is equal to minus 1. According to power rule, power decreases by 1 and the result will be multiplied by the same power. So here what I am going to write, the power of this one is x power minus 1. It is decreased by another one here. So minus 1, and this result will be multiplied by the same power minus 1. So d by dx of 1 by x can be written as x power minus 2 into minus 1 minus 1 by x square. This is the derivative of 1 by x. D by dx of 1 by x is minus 1 by x square. Now second problem, d by dx of 4 by x cube. Here, d by dx of 1 by x cube, because this is a constant into variable, this can be written as d by dx of 4 into 1 by x cube. So this is a constant into the variable here. So bring the constant outside. So I brought this constant. This is 4 into d by dx of x cube. This one is 4 into d by dx of x power minus 3, because x power plus 3 will goes up to become x power minus 3. Now we can write the 4 already we brought it outside. Now we use this formula, power formula. Power reduces by 1 and that result will multiply by the same power. Power reduces by 1, that is x power minus 3 minus 1. Multiply this result with the same power, that is minus 3. So this will become 4 3s are minus 12 into x power minus 4. So this will become minus 12 by x power plus 4. So this is the solution for this d by dx of 4 by x cube. Now the next problem, d by dx of x power 1 by 2. Here already the power is given, so the answer directly we can write x power reduces by 1 multiply with the same power. Repeating, power of variable, here x is the variable, power of variable is reduced by 1 coming and the result is multiplied by the same given power in the quotient. Same given power in the quotient. In the quotient given power is 1 by 2. So that way I am multiplying this with 1 by 2. So the answer for this one is x power 1 by 2 minus 1 will become minus 1 by 2 into 1 by 2 will become 2. This will become 1 by 2. X power minus 1 by 2 and comes down. X power plus 1 by 2. This is nothing but 1 by root x, because x power 1 by 2 is root x. The same question can also be written as d by dx of root x. Directly you can write 1 by 2 root x is the standard form and the standard value that we can remember directly. And now fourth problem, d by dx of x power 7 by 4. Here also the constant is 1 by 4. This is 1 by 4. D by dx of x power 7. This is 1 by 4. Once again we will remember this one. The power of the variable reduces by 1 and the obtained result is multiplied with the same given power in the question. The same thing I am going to apply here. The power reduces by 1 and this result is multiplied by the power given in the question. So 7 into 1, this becomes 7 by 4 x power 6 is the answer for this x power 7 by 4. Now, fifth problem. In this problem, d by dx of 3x squared, first bring the constant outside, differentiate only the variable, and now we know the rule. The power reduces by 1. Multiply this with the power given in the question. So 3 into 6 x power 1 or 6x is the answer for this one. Now the next one, d by dx of minus 3x square, which can be written as here minus 3 is the constant. So bring the minus 3 outside. So this will become minus 3 d by dx of x square, which is given by minus 3 into, and now the rule is power rule, reduce the power of the variable by 1, that is x power 2 minus 1, multiply this with the same power that we obtained here, minus 3 into 2 is minus 6, x power 2 minus 1 is this, so this is minus 6x. Now the next problem, y is equal to x power 4 plus 12x. Now, how to find the derivative of this one? We need dy by dx. Now, for this we are going to write dy by dx. Here we have two terms. So, derivative of a given function with two or more number of terms is sum of the derivative of each individual term with respect to x. So this can be written as a d by dx of x power 4 plus d by dx of 12x. In this, once again the same rule, power reduces by 1, multiply with the same power. Here 12 is the constant, bring it outside. Now this will be x power 1, this will become x power 1, reduced by 1 into multiply with the same power. So this will become x cube into 4, 12 into x power 0 is 1 into 1. So answer 4x cube plus 12. This is the derivative of this one. Now the next one, eighth problem. Y is equal to x cube plus 4 by 3 x square minus 5x plus 3. So we are finding derivative of y with respect to x, that is d by dx of x cube plus 4 by 3 x square minus 5x plus 1. Now this is also, there are four terms, differentiate each term with respect to x to find out the value. So this will become d by dx of x cube plus d by dx of 4 by 3 x square d by dx of minus 5x d by dx of 1. So now here we will write 1 by 1 d by dx of x cube, power reduced by 1 is x square into 3. So directly you can write this as 3x square plus 4 by 3 is a constant. Derivative of x square is power reduced by 1 is x power 1 into 2, which is nothing but 2x minus 5 into derivative of x with respect to x is 1. And the derivative of 1 with respect to x is always 0. Derivative of a constant is always 0. So then the answer is 3x square plus 8 by 3x minus 5. So this is the answer for this given problem. Now the next problem, find the derivative of t square minus 1 by t square plus 1. If you observe this, students, clearly, this is one term, this is another term. Let us say you take this term as u, this term as v. So this is a division rule or quotient rule. In this d by dx of u by v can be written as v into du by dx minus u into dv by dx by v square. This is the formula that we are going to use to solve this problem. But please remember, here I am not writing dy by dx because here in the given problem x term is not present. This consists of t. So this is a d by d of dt of, because with respect to t only we can differentiate this one. D by dt of u by v will become d by dt of du by dt of v minus u into dv by dt of u by v square. So I am going to write first term v is a t square plus 1 into d by dt of u t square minus 1. Then u t square minus 1 into d by dt of v t square plus 1 divided by square of the denominator. Denominator is v, which is equal to t square plus 1. This will become t square plus 1 whole square. Now we will solve the problem. This is a value brought outside. Now derivative of t square will be 2t. Derivative of 1 is a constant, is always 0, minus this term t square minus 1. Derivative of 2 square, t square is equal to 2t plus derivative of 1, constant is always 0, divided by denominator t square plus 1 whole square. Now this will be written as 2t into t square, 2t cube plus 2 into 1 is 2t minus t square into 2t, 2t cube minus 1 into 2t minus 2t by t square plus 1 whole square. You can see if we have 2t cube minus 2t get cancelled. This 2t minus of minus of plus 2t, which is equal to 4t by t square plus 1 whole square. This is the derivative of the given function, which is equal to 4t by t square plus 1 whole square. Now the derivative of y is equal to x square minus sin x. Here also we have two different terms. This is the first term, this is second term. So dy by dx, because both can be differentiable with respect to x, is given by d by dx of x square minus d by dx of sin x. Now you can write, this is a fundamental formula, x square derivative is 2x minus derivative of sin x will become cos x. So this is the 10th problem. Now the 11th problem. Here y is given as x square into sin x. This is also u into v. u into v d by dx of uv is given by u into dv by dx plus v into du by dx. So I am going to write dy by dx written as, first you keep u outside. So x square you keep it outside. Then the derivative of the other term plus, now this outside derivative of the first term, it is x square. Now you can write x square. Derivative of sin x is cos x plus this is sin x. Derivative of x square will become 2x So answer is x square cos x plus 2x sin x is the answer for this question. The next one, y is equal to sin x by x. So this is in the form of y is equal to u by v. So we need to use quotient formula. So dy by dx is given by first v into derivative of numerator minus now numerator into derivative of denominator divided by x square. So this is dy by dx can written as x into derivative of sin x is cos x into minus sin x. Derivative of x with respect to x is always 1 divided by x square. So answer is x cos x minus sin x divided by x square. So this is 12th problem. Now 13th problem. Y is equal to x square plus cos x. Now I want derivative of this. In these two terms we have x. So both are differentiable with respect to x. So for these type of functions we can write total derivative of y with respect to x is given by derivative of the first term plus derivative of the second term here. Derivative of first term, once again the power rule, power reduces by 1 and multiply the same thing with the same power given in the problem. So this will become x square become x power 1 into 2. So this will become 2x. Derivative of cos x is equal to minus sin x. So the answer is 2x minus sin x. Now, the 14th problem, y is equal to sin x into cos x. So, this is in the form of u into v formula. So, u into dv by dx plus v into dv by dx. The formula d by dx of u into v is equal u into dv by dx plus v into du by dx. So I am using this formula, I am writing this as dy by dx is given by, first u is sin x, d by dx of cos x plus v is cos x, d by dx of sin x. From the students, this dy by dx to written as sin x. Derivative of cos x is minus sin x plus cos x. Derivative of sin x is only cos x. This will become minus sin square x plus cos square x. This is the derivative of sin x into cos x. 15th one. They have given y is equal to tan x and we want to find out derivative of tan x. Directly we can write the answer, but here we will use the concept that we studied in 10th class. Tan x can be written as sin x by cos x. Now the given formula, given problem, convert into u by v here. So here this is u, this is v. So now I am going to use this one. Y is equal to, the given problem is tan x only, which can be written as a sin x by cos x. Now u by v formula, v into du by dx minus u into dv by dx plus v square. So now directly I am writing dy by dx can be written as first v, that is a denominator. In denominator we have cos x. So I am writing cos x derivative of numerator sin x minus, now numerator is sin x derivative of denominator divided by v is nothing but cos only, v square is cos x whole square. Now this can be written as cos x remains as cos x, derivative of sin x is also cos x minus sin x, derivative of cos x, students, this is minus sin x by cos x whole square known as cos square x. Now this can be written as cos x into cos x, cos square x, minus of minus will become plus, sin x into sin x, sin square x divided by cos square x. But we know from trigonometry identities, sin square x plus cos square x is equal to 1. So this will become 1 by cos square x, which is equal to secant square x. So derivative of tan x is d by dx of tan x is secant square x. That also better to remember, but better to remember this method of solving the problem also. Now 16th one, y is equal to 3x plus cot x. So I want dy by dx. Before writing this denominator, that is variable, first we have to check whether the first term is variable, having a variable or not. So we have x here, so it can be differential with respect to x, and here also we have x, which is also differential with respect to x. Now we can write dy by dx also. d by dx of 3x, d by dx of cot x. So what is this d by dx of 3x? 3 you bring it outside, dx by dx this will become 1. Cot x derivative is tan x derivative is secant square x, cot x derivative is minus cosecant square x. So the answer for this one is 3 minus cosecant square x. Suppose f is a function, which function? Differential function. X is a differentiable function with respect to x, then so given function is f, this is the differential function, and its derivative f dash is called first derivative of f, also called f prime. Now f prime is also a function which will have its own differentiation, and that is given by f dash whole dash, or f prime whole prime is given by f double prime or f double dash. For example, the given function y is equal to f of x. Now you can write dy by dx can be written as f dash x or f prime x. Now this is called first derivative of y. Now second derivative of y, we write this as d by dx of dy by dx. So I am differentiating this with respect to x, which is given by d square y by dx square, Leibniz equation, and this is how we can represent the double differentiation. So we will solve a problem based on this double differentiation. Y is equal to x into cos x. Find y dash, y double dash, or y prime and y double prime. So this is a given question. Now we are going to find out y prime first, or dy by dx. Y prime is also called dy by dx. So dy by dx, which is called y prime or y dash. First, this is u into v formula. So for uv formula, x into d by dx of cos x plus cos x into d by dx of x. Now you can write x into derivative of cos x is minus sin x plus cos x. Derivative of x with respect to x is equal to 1. So y prime are also called, this is called first derivative of y. First derivative of y, we call it as y prime or dy by dx, also called dy by dx, which is written as x into this minus x sin x plus cos x. So this is our first derivative, students. Now I need second derivative. To find out the second derivative of y which we can write it as y double prime or y double dash, and also written as d square y by dx square. So I have to differentiate this with respect to x again here. So for this, what we are going to do, second derivative, so I am going to write d square y by dx square, which is also written as y double prime. Here you can see this is a product plus this is a product. So I can write d by dx of that function minus x sin x plus cos x. Now y double prime is equal, this is uv formula because u into v. So here you can see this is u and this is v, u into v. So u into derivative of v sin x plus sin x into derivative of minus x. So this part is over. Then the next part is d by dx of cos x. d by dx of cos x. Now we can write minus x. Derivative of sin x is cos x plus this is first part is over. The second part sin x. Derivative of minus x is minus 1. Derivative of cos x is minus sin x. So this will become minus x cos x minus sin x minus sin x. So this will become minus x cos x minus 2 sin x. This is the double derivative of that given function f.